In this video, we're going to walk through a quick example for calculating the small sample hypothesis test for mu1 minus mu2. And again, we have three different conditions that we need to make. First is that they're randomly selected values for each sample. The second is that both populations are approximately normally distributed. And the third is that sigma 1 squared is equal to sigma 2 squared. And then we have the fourth condition, which is to make sure that we can use a small sample hypothesis test, where we need to check to see that n1 is less than 30, which does not appear to be the case, or that n2 is less than 30, which does appear to be the case. So since we have n2 is less than 30, since n2 is equal to 20, we can use our small sample hypothesis test. Now the hypothesis test that we're actually going to be conducting today is for h0, where we have mu1 minus mu2 is equal to a d0 value, d0, and we're going to set that equal to 0. So we're basically testing to see if mu1 is equal to mu2, and then we can have multiple different alternative hypotheses, but in this one we're just going to say HA is mu1 minus mu2 is not equal to d0, where we have again d0 is equal to 0. So again, we're just checking to see if our mu1 and mu2 values are the same or if they're different. And now we're just going to do some calculations up front since we know we're going to need the values. We're going to calculate our SP squared, where we have the formula for that is equal to our n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared. And all of that is over our n1 plus n2 minus 2. And in a previous video, we calculated that all out to be, after plugging in all the numbers, as 2.67. We're also going to quickly calculate our t sub alpha over 2. So we have t of alpha over 2 with the degrees of freedom. And for our degrees of freedom, we're going to get 40 plus 20 is equal to 60 minus 2. So again, the denominator for our fraction for SP squared. And since we don't have 58 in our table, we're going to substitute in 60 since it's the closest value in our table. And we're going to get t of alpha over 2 since we have an alpha of 0.05. We're going to have t of 0.025 with 60 degrees of freedom is equal to 2.000. Now we're going to use all this information as we actually conduct our test. So to conduct our test, we need to use our test statistic, t, which is equal to, we have our x1 bar minus our x2 bar, all that minus our d0 value, and divide that by the square root of SP squared times 1 over n1 plus 1 over n2. Now plugging in all these values, we get our 1 minus 0, since we have 8 minus 7 for x1 minus x2, or x1 bar minus x2 bar, minus 0, so we get 1 minus 0. Divide that by the square root of 2.67, multiplied by 1 over n1 plus 1 over n2 is equal to 0.075, which gives us 1 over the square root of 0.2, which gives us 1 over 0.447, which comes out to be 2.234. Now since we're doing the not equals hypothesis test, we're doing a two-sided hypothesis test, so we're going to check to see that t is equal to our 2.234. The absolute value of that, which we're good with right now, is greater than our t sub alpha over 2, which is equal to 2.000, which is t of alpha over 2. So since we have our t value, or our test statistic, is greater than the t of alpha over 2 with our 58 or 60 degrees of freedom, we successfully reject our null hypothesis and accept the alternative, where our alternative is that the mu's for our two different populations, so mu1 and mu2, are in fact different.